Hey everybody, here's a warm-up for you, so why don't you go ahead and pause the video, give it a try, and then when you are ready, unpause it to see your answers. All right, so the first question, I just put them on separate slides so I have more room to write. Solve the following quadratic equations in the form they are in, meaning don't convert them, don't move them around, anything like that, literally just solve them. Notice how I'm using the phrase solve versus find the x-intercepts, because both of these guys already have a 0 in place. That's literally the only difference. Other than that, the procedure and the process are exactly the same, okay? So for the first one, I'm going to add positive 36 to both sides. Then divide both sides by 3. Take the square root of both sides, so the left side's just x minus 1. And I don't know the square root of 12, that's not a real nice number, so I'm just going to write plus or minus square root of 12. When I add 1 to the other side, don't forget to put the 1 in front of the plus or minus. And then here's the last step. Square root of 12 might reduce, so I need to think about what are all those perfect square numbers. So 4, 9, 16, 25. The largest of those that 12 divides by nicely is 4. The square root of 4 is 2, and we don't know the square root of 3, so the square root of 3 kind of stays put. So here's what I was talking about in the last video. This is when you're solving the quadratic, this is your solution. Do not write these as x-intercepts, okay? So there's a slight difference between solve the quadratic and find the x-intercepts of the quadratic. And the difference is, are you plugging in 0 or is it already there? And how do you write your final answer? But the actual process from start to finish is very, very similar. So like this one, for example, if I wanted to solve it, I'd divide both sides by 3. And 0 divided by 3 is just 0. And because they're factors, I set each factor equal to 0. So I get one answer is 6, and the other one is negative 6. Notice how I'm not writing them as x-intercepts because it's just asking me to solve. The second question on the warm-up wants you to solve by converting. So the first thing you have to do is set every quadratic equal to 0. But you also want to keep this x squared positive. So since this guy is already positive, I'm going to move everything to the left side of the equation. If that x squared was negative, I might want to move everything to the right side of the equation and have it be 0 equals blah, blah, blah. So it just kind of depends. Personally, for me, factoring is easier if it's possible. So if there are two numbers that add to give me 5 and multiply to give me negative 6, I think that's the better route to go. Like for me, that's easier. So let's see, 6 and negative 1. Let's see. Yep, that works. So when it says solve, one of my answers is negative 6. My other answer is positive 1. Okay. If you wanted to complete the square, I guess you could, but here's the problem with completing the square. I don't want to take half of 5 and square it. It's going to give me decimals, right? So I think factored form is probably the right way to go. This one on the right, again, first thing you want to do is move everything to one side of the equation, and I want to keep that x squared positive, so I moved everything to the left side. If it's factorable, awesome, but to multiply to give you 8, you can do 1 and 8, or you can do 2 and 4, and neither of those are going to add to give me negative 4 somehow. So I think I'm kind of forced into completing the square. So I haven't done a diagram one in a while, so let me do a diagram one. You have negative 4 x's, so there's negative 2 on either side. So completing the square would be x minus 2 quantity squared. And there's 4 in the corner. And you ask yourself, do I have 4 pieces? No. Do I have more than 4 or less than 4? Well, I have less than 4. Not only do I not have the 4 here, but I'm also down 8. So I actually have 12 less from what we're looking at. So now to solve it, okay, because that's what they're asking me to do, add 12 to both sides. Square root both sides. Don't forget to put plus or minus square root of 12. And then add the 2 over. Square root of 12, you have to check to see if it simplifies, and it does. We can divide 12 up into 4 times 3, and square root of 4 is 2, but square root of 3, we don't know what that is, so that kind of stays put. And so there are my answers. You can absolutely leave your answers just like this. If you also want to write it as 2 plus 2 root 3, you can. If you want to write it as 2 minus 2 root 3, you can. All right, so here's a thought, and here's what today's video is going to start us thinking about. What if the quadratic's not factorable? What if converting it to vertex form gives us decimals or difficult to work with numbers? Like, for example, we didn't want to complete the square for this guy, right? What if we had something like that? And what if it's not factorable either? So looking at this first one, okay, we kind of ruled out completing the square because of the odd number in the middle. But what if also it wasn't factorable? Do we just say, well, I can't solve that quadratic and give up? That's not quite how that works. So we use what's called the quadratic formula. Some of you guys have heard of this before or seen it before, some of you haven't. My favorite way to teach this is by teaching you this super obnoxious song. The YouTube link is on the bottom. I also have it pulled up in my tabs here. I guess, there we go. So just listen in. Normally what I would do in class is I'd make you guys sing it out loud really obnoxiously to try to annoy all the other math teachers, just because why not, and it's fun. But I will tell you this. As obnoxious as this song is, it will not leave you. Like, I've actually noticed in my Algebra 2 trig students, the students who know this song completely remember the quadratic formula 2 years later. And the students who did not learn the song, they go, oh, there's a negative b, and they kind of hesitate. So as dumb as this video is, it's definitely going to stick with you for 2 years. So listen up. So basically what I would ask you guys to do is I would then sing it with you guys really loud. And I'd say, nope, do it again. Nope, do it again. And we get to the point where we're going to obnoxiously sing it for everyone in our hallway. And then I ask Miss Bradford later in the day, hey, did you hear us singing? And if she says no, we didn't do it loud enough. So just kind of a fun way. So this is the formula that you see on the screen. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And you're kind of thinking, okay, but what's A, what's B, and all that? Well, let me show you. Okay, in standard form, the original format for standard form looks just like this. So your A is the number that's with the x squared, your B is the number with x, and the C is the constant, okay? So I have the same equation written twice, okay? Let's do this first equation by completing the square. So again, a lot of you guys really like the algebraic way, so I'm going to do it that way, where I draw my blanks. Because there's a 2 in the front, I can't just take half of negative 8 and square it. It doesn't work. I have to take the 2 out of the picture first and make that a negative 4x. Now I can take half, which is negative 2. Negative 2 squared gives me 4, but technically I didn't add 4. I added 8 to the equation, so I need to subtract 8 over here and bring down the 2. So if I want to solve for the x-intercepts, I plug in 0 for y. I'm going to add 6 to both sides. Divide both sides by 2. Take the square root, so plus or minus square root of 3 equals x minus 2, and add 2 to both sides. Okay, so here's my answer for this one. Here's how you would find it using the quadratic formula. So the quadratic formula, if you sing it, right, and it's going to sound dumb, and I know I'm videoing this, which is nerve-wracking, but I'm going to sing it to you. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And trust me, you will not forget it when you go to take Algebra 2. It's so obnoxious, it won't go away. All right, so my b value is that negative 8 up there, right? So let me actually start with this. So the a value is this 2, because it's with the x squared. My b value is the negative 8 with the x. And my c value is 2, because it's at the end. So that's kind of how that works. So b is negative 8. Notice how I'm putting everything in parentheses. A is 2 and C is 2. Okay, notice how everything's in parentheses. Trust me there. So negative 8 is just positive 8. Negative 8 squared is 64. 4 times 2 is 8. 8 times 2 is 16, so minus 16, all over 4. Now I've got 8 plus or minus, I need my calculator here. 64 minus 16 is square root of 48. Okay, little bit of a problem here. I kind of get stuck unless I want to make it decimals. And notice how, like, shouldn't these two answers be the same because the original equation was the same? So here's a little twist to this. The square root of 48 can be simplified. So I'm going to start this over here so I have plenty of room. So 48 can actually divide by, let's see, 16 maybe? Yep, 16 times 3. Well, the square root of 16 is 4. Now what we can do is kind of use this it's like butterfly technique sort of. Since 8 can divide by 4 and 4 can divide by 4, I can simplify that. 8 divided by 4 gives me 2. 4 divided by 4 gives me 1. And the square root of 3 kind of is just along for the ride. Now notice how this answers the same exact one that we got from completing the square. But here's the most important part from quadratic formula. A lot of students will say, oh, I want to use quadratic formula every single time because it works every single time. And they kind of fight me on it because they're like, well, I don't like converting. But really, look at these two options. Which one's easier? And I hope your answer is completing the square. You've had a lot more practice with completing the square. Solving it, especially once you actually turn it into vertex form, getting to this point's way easier than getting all the way down to here, not messing up any negatives or multiplications or square roots, then remembering to simplifying it, then remembering to do this butterfly technique to finally get down to the correct answer. It's a lot. Okay, here are a couple extra practice questions. We probably don't have time to do it on the video, so I'm going to skip them for now, but this also can be kind of a mini homework assignment for you guys, so I'll go back to it if I have time in my video. But I want you to try these two using the quadratic formula and see how it goes, okay? So, in fact, actually, I just got to my slide that says the rest is on Monday, so this is perfect. So once you try these two, right, so pause the video, give these two a try using the quadratic formula, and then unpause it to get your answer. All right, so in this case, 2 is A, -3 is B, and -5 is C. So negative B plus or minus the square root of B squared minus 4AC all over 2A. So -3 is just 3. This gives me 9. Here's something you have to be careful of right here, you guys. This right here. Okay, so the reason I say be careful is because 4 times 2 is 8. 8 times -5 is -40. Then you're going to say, oh, okay, this is 9 minus 40. Don't forget about this negative right here. It's actually 9 plus 40. Okay, so watch out for your negatives and just be really careful there. If that screws you up, you can even make this plus -4 to kind of help you out. All right, so 3 plus or minus square root of 49 over 4. Well, the square root of 49 is just 7. And now here's how this works. One answer is 3 plus 7 divided by 4. The other answer is 3 minus 7 divided by 4. So 3 plus 7 is 10. 10 divided by 4 reduces to 5/2. So there's one answer. 3 minus 7 is -4, and -4 divided by 4 is -1. All right, let's look at the second mini assignment for you. Okay, negative B plus or minus the square root of B squared minus 4AC all over 2A. Remember, the reason I go faster on these videos, you guys, is because I know you can pause, take your time. You can come talk to me during office hours if I need to clarify anything, okay? So I get 7 plus or minus square root of 73 all over 4. So I need to check if 73 divides by a perfect square. I don't think it does. Divide by 4, nope. Divide by 9, nope. 16 is a no. I know 25 is a no. 36 is a no. 49 is a no. 64 is definitely a no. So yep, literally, that's my answer. I just leave it like that. Nice job, you guys. Enjoy your weekend, and I'll check back in with you next week on Monday.